Welcome to Minimal Tech. Today, we are in an era of AI large model explosion. We can name various large models: Llama 3, Cloud, Gemini, Grok, and so on. But often, we do not make full use of them. Most of the time, we just use large models as search engines or translation tools. Large models can do far more than that. To use large models for specific needs, we need to develop specialized applications. But most people do not have the ability to write code. The emergence of Dify has successfully addressed these pain points. Dify is a development platform aimed at creating AI applications through no-code. Using a visual interface and rich built-in components to build applications. It applies AI technology to specific needs. With minimal coding, you can quickly create, deploy, and manage AI applications. Dify provides a powerful visual canvas to construct and test AI workflows, allowing for easy prototyping and scaling of AI solutions. This feature supports creating complex workflows visually, making it accessible even to those with minimal coding experience. Seamless integration with hundreds of proprietary or open source large language models from dozens of inference providers and self-hosted solutions, covering GPT, Mistral, Llama 3, and any OpenAI API-compatible models. Extensive RAG capabilities that cover everything from document ingestion to retrieval, with out-of-box support for text extraction from PDF, PPT, and other common document formats, making it easier to handle and process large volumes of text data. Dify provides over 50 pre-built agents templates for rapid AI application development. Users can also define agents based on large language model function calls or React from scratch, helping you to complete tasks such as financial report analysis, report writing, logo design, and travel planning. Dify platform offers both cloud services and local deployment options. Cloud service users can get 200 free GPT-4 cores as a trial. Beyond that, a subscription costing $59 per month is required to continue usage, which is not cheap. Fortunately, Dify is open source and can be deployed locally by Docker for free using. According to Dify's official documentation, running Dify locally requires certain system and hardware specifications. For example, on Mac, it requires macOS version 10.14 or higher, a dual-core CPU, and more than 8 GB of memory. For Linux and Windows system requirements, please refer to the official documentation. I will include the documentation link in the video description. Next, let's follow the documentation steps to deploy Dify locally. First, run the command in the command line tool to clone the Dify source code locally. Second, before starting Dify, you need to check the installed Docker version. Run Docker Compose version in the command line tool. If your system has Docker Compose v2 instead of v1, use Docker Compose instead of Docker/Compose. You can see I'm running v2. Navigate to the Docker directory in the Dify source code and execute the following command to start Dify. The error occurred because Docker was not running in the background. After starting Docker, run the start command again. Wait for Docker to install Dify locally. After installation completed, run Docker Compose PS to check if the installation was successful. You will see a system prompt indicating a successful installation. If you need to upgrade Dify, you can run the following command. Finally, visit HTTP localhost install in your browser to use the locally deployed Dify. Before using Dify locally, you need to sign up by entering your email, username, and password. The password must be a combination of letters and numbers and be longer than 8 characters. After registration, log in with the registered email and password. After logging in, first enter Dify's Studio interface. Through this interface, we can visually create 3 types of AI applications: chatbot, agent, and workflow. Since Dify is deployed locally, we first need to configure the large language models to create AI applications based on them. Click the avatar in the upper right corner, select Setting Model Provider. You will see that Dify supports proprietary large language models from mainstream inference providers. We can also use Ollama to deploy self-hosted large language models. For how to use Ollama to deploy self-hosted large language models, click the tag in the upper right corner to view the previous tutorial on Ollama. Today, I will demonstrate using groqcloud's API to call Grok's cloud models. Grok is a company focused on accelerating AI inference. They have developed a new inference engine called LPU. LPU is several orders of magnitude faster than GPU and CPU in large language models and generative AI inference tasks. Currently, Grok has developed Gamma 7b, Llama 2 70b, Llama 3 8b, 70b, and Mistral on their cloud service, supporting online operation and API calls. Most importantly, it is completely free. For how to apply for Grok's Cloud's free API, I won't be detailed here. Please click the tag in the upper right corner of the radio to view the previous video. Copy the Grok Cloud API key, return to the Dify configuration page, and paste the API key in the Grok Cloud configuration. After configuration, you can see that the 4 models provided by groqcloud have been configured in Dify. Finally, set the system default model to Llama 3 70b. After setting up, I will demonstrate how to use Dify plus Llama 3 to create an AI application through workflow. All operations for creating AI applications in Dify are done on the Studio page. We can customize the application according to our needs. Dify also has a variety of built-in application templates. We choose a template corresponding to our needs to quickly create AI applications, and adjust the created application modules to precisely fit. Taking the email assistant workflow templates as an example, click the email assistant template and name the application Minimo's Email Assistant. Click Create. On the canvas, you can see various preset blocks are connected to form the entire AI application. Right-click on a black area of the canvas to create blocks. You can add various types of blocks. You can also add built-in tools supported by Dify, such as Google, Wikipedia search, etc. To use these built-in tools, you need to obtain authorization API keys. The workflow process must include the start and end block for input and final result output. Click Run to see the effect of the start block. The start block contains 3 input fields, which are input text field, used for entering the email content, user request field, used for entering basic needs such as summarizing, replying, composing, and improving email content, hot polish field, used for entering fine-tuning needs, such as compressing words, simplifying email content, rewriting in the author's tongue, etc. Double-click a component to edit it. Select the field type at the top can switch the component to an input box, drop-down selection, etc. Turn on the optional switch at the bottom to switch the component to a required field. There are two question classifier blocks on the canvas, corresponding to the user request field and the how polish field in the start block. The function of the question classifier block is to organize the content passed from the start block into prompts and submit them to the large language models for classification and pass them to subsequent blocks for processing. Here, the default model set by Dify is GPT 3.5. Click it to change the model to the groqcloud Llama 3 70B we configured earlier, and set the max token to a large value such as 4096. The LLM block receives information passed from the question classifier block and processes it using the AI large model, then outputs feedback. Taking the summary block as an example, the system input box contains a preset prompt, summarize the email content. The email content is from the input text field in the start block. Next, the LLM block passes the generated content to the template block. The model should also be changed to Llama 3 70B as in the previous step, with max token set to 4096. The template block receives the content generated by the LLM block, converts the text into HTML format through the Jinja engine, and parses it to the end node. The end node outputs the HTML text received from the template block to the user. Before running the application, make sure to change the default GPT 3.5 model in all blocks to the previously configured Llama 3 70B with max token set to 4096. After completing all configurations, search for an email text and copy its content. Click Run in Dify. Paste the email content in the email input box. Choose the basic need, reply to email. Choose the fine-tuning needs, improve writing and clarity. Click Start Run. You can see the information flowing along the corresponding blocks on the canvas. After a while, you'll see the rewritten email content preceded by the large language model. This is an example of developing an AI application using Dify plus groqcloud's Llama 3 70B large language model without writing a single line of code. If you like my video, please like and subscribe to my channel. See you next time.